Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem in the list is count good nodes in binary tree. Let's go to the problem on LeetCode. Given a binary tree root, a node x in the tree is named good if in the path from root to that node x, there are no nodes with a value greater than x. Return the number of good nodes. So we need to find the number of good nodes in a given tree, and we have the root reference. So for example, here in this first example we have root reference 3. Now we need to find the good nodes in this tree. So what is a good node? Good node is a node, any node, if there is a path from root to that particular node, in that path there is no node greater than my current node x. So let's say all of these nodes would be x, but for a given node, let's choose node 4. Now node 4 is a good node, and why it's a good node is because if you see a path from root to 3, in this path there is no node that is greater than 4. There are only basically two nodes until here, which is 3 and 4, and 4 is greater than 3. If this particular node was maybe, let's say, 2, then it would not be a good node. It won't be a good node. All right. And how are we going to do it? So we're going to basically use DFS, and we're gonna basically we can use any of the traversal method, which is pre-order, post-order, in-order. It's just we have to maintain the max value or the max node that has been seen so far. So whenever I reach a particular node, then I can determine if my current value is greater than or equal to the max node that I have seen so far. So for example, when I start my DFS at root node, then I will send in the value, the root 3, and max value seen so far is also 3, because initially it's the root value. We can just send anything, all right? Like not anything, the root value, so that like that is the legit value that we can set, because it is equal to or greater than my current value, so it will be included as a good node. So root node will always be a good node. So I send in 3. Now it's gonna call 1, and max node that I have seen so far is also is 3, so I'm sending it over here. This will be added as good node. So good node will be good nodes basically will be 1 initially, and then it comes to 1, then it's going to check if it is greater than or equal to 3. It is not, so it's not a good node, but it's going to call its children, makes a call to 3, and then it's gonna basically keep sending 3 as the max nodes seen so far, and that value we will update basically with max current value or the max value seen so far. So here as well, it's gonna make a check, and then this is a good nodes. We will add it to our result, and from here call will return back to here. It's gonna make a call over here. Max value seen so far is gonna be 3. It is greater than 3. Then we'll add one more good node to our answer, and then here max value seen so far will be basically 4, so it will basically call the value as 4. Basically this will become 4 here, so this will be 4. Max value seen so far is 4. Then it's going to make a call here. It's not a good node because max value is 4, it's 1, and over here max value will basically become 5, and this will add one more value to my answer, and the answer will be 4. So let's write a DFS function that will basically calculate the will return the number of good nodes, comparing them with the max value seen so far, and at each recursive call we will basically we will update that max value seen so far. All right. Okay. Okay, let's write our solution. That is initially, if root is none, so there are no good nodes, so just return 0. All right. What we can do right now is have a DFS function that will basically call root, and basically we need to traverse all the nodes, and we will basically maintain a variable called max value seen. So let's call it max value seen, and that would initially be just the root node. Now if not root, then I basically return 0. Okay, otherwise what I'm going to do is I have to find out if the current node is good or not. Let's say initially, if current node is good, that means I will add 1 to my answer, otherwise no. So let's say answer initially, let's say I'm just assigning a local variable. Answer is basically 0, and if my root dot value is greater than equal to max value seen, that means what? That means what? My answer becomes 1. Okay, and I will return answer plus, I'll make the call to left and right children. So that is basically, I call on left, and max value will be max of my current max, basically max value seen so far, or root dot value. All right, and the same goes for our right child. We need to find out the good nodes from the right side as well. Okay. All right. Okay. So that is right. And finally I'll just, let me zoom out and just return my DFS on root, and basically if root is none, it will just return 0. It's an edge case, otherwise it will go inside, and here I'm sending root dot value as the initial value, because the root will be a good node always. So here it will make a check and add 1 to our answer. You can simplify this, just like have the condition over here into just some, like, everything right over here. Otherwise this is also good. Then okay, let's try to run it on our examples. All right, passes the examples. Let's try to submit it. Awesome. Time complexity is big of n is the number of nodes, and space complexity is big of h is the height of the tree. All right, let's go back to AlgoYogi, mark this problem done, and see you guys in the next problem. Please like, share, subscribe. Boom. Just kidding.